Hello, this is the second half of Chapter 11 where we look at two-factor or two-way analysis of variance. So I put notes online. Hopefully that will help you. I'm going to kind of work our way through it and show you how to do it in PHStat and then explain how you interpret the results. So what two-way analysis of variance does is it lets you examine two factors or two independent variables at once. So you have two independent variables and one dependent variable. The dependent variable, remember in our first example, was the actual sales, and then our two independent variables in this are the sales location in the store, which is shown in these columns, as well as a second independent variable, mobile payments. So whether or not they allow people to make mobile payments at the location of the sale, and they looks like to me they have samples of 5 no's and 5 yeses at each of these 4 locations. So anyway, so that's how the data is set up. When you set this up, you've got to define a few things. So number one, R equals the number of levels of factor A. In this case, it's whether you allow mobile payments or not, and there are 2 levels there, no's and yeses. And then C is the column variable, and this is the number of levels of factor B. In this case, it's our different sales locations. There are 4 of those. The number, the N prime that they've got there is the number in each location for each payment allowed, and that would be 5. And so since we've got 5 times 2 is 10 times 4 gives us 40 total observations. So again, you could do this by hand, but I don't know why anybody would want to do it that way. So you're going to want to do this using PHStat. So to use it in PHStat, what you do is you go to your spreadsheet. You're going to open up a file called mobile. What is that file called? Anyway, I forgot that. Anyway, open up the file. It's called Mobile Electronics 2. It's in your set of data, and you will see that it's set up just like it was on the screen. As a matter of fact, I just copied it over into the Word document. To run your two-way Anova on this, you're going to go to PHStat, and you're going to pick off multiple sample tests, and down here at the very bottom is something called two-way Anova with replication. The with replication is the only choice we have. We talked about that, I think, earlier this semester, but that just means that you put each possible sample back in and have a possibility of selecting it again. So anyway, here's our dialog box. It looks very much like the dialog box that you had with single factor Anova, except there's something called a cell means plot down here. So our sample data range, in this we're going to put, since we're doing two-way Anova, we're going to put in our row variable, which is our mobile payments, as well as our column variables. And we're going to click on this box that says cell means plot. We'll use that later. I will explain. And you just say OK, and all kinds of things happen here. So here is our output. I'm going to go back to Word so you can see it, and it should create the cell means plot on another sheet. So in Word, I saved all of these for you, and you can see same thing here. Here's my analysis. So you're going to do 3 hypothesis tests for this, and the hypothesis test p-values are located right here in the p-value column on the Anova table, and there's one for sample, columns, and interaction. Sample would be the row variable, columns would be that's obviously the column variable. In our case, our row variable is whether we allow payments to be done by mobile or not, and then column variable was the actual location of the devices, and then the interaction is the relationship between the two. So our first, and this is our cell means plot, which we'll talk about in just a few minutes. So our hypothesis test, our first hypothesis test is looks at the interaction effects between the payments and the sales locations. So basically, your null hypothesis would be written out in words. All these are written out in words, and it will say something like there's no interaction effect between the 2 variables, payment and sales location. And then your alternative hypothesis will just say there is an interaction effect between the two variables, payment and sales location. To test for this, you look at the interaction row in the Anova table. And if you go back up to our Anova table and you look at the interaction row down here, third one, you will see a p-value of 0.7469. What that tells us is that this p-value, 0.7469, is certainly not less than our alpha level of 0.05, so we cannot reject the null hypothesis, and we conclude that there's no interaction effect. It is also a good idea, once you've looked at your p-value here, to also go back and look at the cell means plot. If the sales are the same, depending on whether they allow mobile payments or not, these lines won't be on top of each other, but they'll look like they go kind of the same place, and these do. So that tells me there's no interaction effect. Our second hypothesis test is looks at the sales locations. This is my column variable, and my null hypothesis will say there's no difference in the sales at the different locations they put these items in. And my alternative will say that the sales at the locations are different. To test the hypothesis, we're going to use the sample row in the Anova table, and I'm sorry, the column row, I'm sorry, that's wrong. In our Anova table, and our p-value is 0.0000. I wrote the wrong thing in here. Okay, I'm going to use the column row. Column row in the Anova table. And so we're going to report the p-value as being less than 0.0001. Remember, if it's reported as being 0.0000, then we just put a 1 in that last decimal place and say it's less than that. Since this is less than 0.05, we reject our null hypothesis, and we conclude that the actual sales does differ by the location it is in the store. And then our third hypothesis test, this uses the samples row. In the Anova table, it looks at the payment methods and whether they affect sales. So our hypothesis, our null, would say there's no difference in the sales depending on whether mobile payments are allowed or not, and our alternative would say there is a significant difference in the sales depending on whether the mobile payments are allowed or not. And we use the samples row in our Anova table, which also has a p-value of 0.0000, and there it is up here at the top. And again, we look at that, and we're going to use less than 0.0001 because, again, if it's reported as 0.000, we put a 1 out there on the end. So we reject the null hypothesis, and we conclude that sales does differ depending on whether they allow mobile payments or not. So that's our basic hypothesis test. We can also, for this data, do multiple comparisons between the locations, and it works the same way as it did in our basic one-way Anova. So you just are going to go back and run a one-way Anova, omitting that first column of data that has the mobile payments in it. For this one, our sample size is actually 40, and the number of groups is 4. The studentized range table, which is found in the back of your book, again on page 650, goes from like 30 to 40. So what you do is when you subtract your 4 from 40, you get 36. It's not on the table, so pick the closest number, which is 40. So you look at 4 and 40 to do that with. 4 and 40. And you're going to get your value that way, which ends up being 3.79. So to do this, you would, I'm sorry, my phone keeps ringing. you would go back to your data, and you, in PHStat, pick off the one-way analysis of variance under multiple sample tests, and you would go ahead and pick your data off, but again, leave out this first column, pick off these four, and then go ahead and have it do the Tukey-Kramer procedure. That will just tell you whether these four groups differ, and then say OK. And this is the Q statistic I said we had to look up in the table, which again is 3.79. So I put in my 3.79, and I press enter, and that's going to give me my information. And here's my Anova, and there are differences in the groups, well, which we knew with our smaller data set, but our larger one shows there are differences. And then our Tukey-Kramer, which I copied over into Word, looks something like this. And it looks to me like, looking at this, that, and I kind of tried to draw a picture, not very well, but I tried. Group 2 seems to be different from all the other groups completely. Group 4 seems to kind of straddle. It's not different from 3, and it's not different from 1. So clearly I can see that Group 4 isn't different from 1 or 3, but Group 2 is different from the others. And you would just explain that if you were dealing with this. Anyway, hope that helps with Anova Part 2. Thanks a lot. Bye.